And next speaker is Yang-Soo Kim from Samsung Construction and Technology from Korea. The title is Building Heating and Cooling Load Analysis of Super Tall Building Considering the Vertical Microclimate Change.
Hello, ladies and gentlemen. I am Yang-Soo Kim from Samsung CNT, and this paper is conducted with Doosam, professor of Sungkyunkwan University. The topic of this paper is building heat and cooling load analysis of super tall building, especially considering the vertical microclimate change. These are the contents of this paper, and I'll start from beginning to introduction and vertical microclimate change, and explain about the simulation conditions, and move on to the result and conclusion. In introduction, I want to speak about why and what and how about this. And this is beginning of why is this research is conducted. It's very obvious that the high-rise buildings are increasing, even though there were economic world crisis happened. And its trend is getting taller and taller, and is becoming complex building, not just having one function. And it has a lot of advantages. The tall buildings can be the landmark of the city. It can be a city's image, and of course it has a better view, so people can see a better outside. And in terms of urban design, it can provide very effective land use. City can be dense, and because of that, we can save price that we have to invest for infrastructure. However, there are so many disadvantages in high-rise building as well. One thing is the increase of energy use and higher investment cost in early stage. The second one is the green growth is a very big flow of these days, like a carbon emission, renewable energy, green building certificates, the things that all we want to think about here, those are the very important factor these days. So my question of why is growing need for sustainability of tall building. That is quite name of this session. And let's move on to the what question. What should be done? The general building and super tall buildings have a lot of differences, beginning from the temperature and wind speed, stack effect and usage, and effect from the solar. Those have a lot of differences. So these are the things that I wanted to talk about. And about the how question, so how can I do with this? In normal buildings, to design sustainable building, then people have to do the research in advance of the building's construction. And how we do it is very obvious, that we do a lot of simulation. So we use weather data that is measured mostly near the ground level, and we think about the relationship between outside and inside of the building. These are a very typical way. But if we want to think about the taller building, then we have to think more than that. The weather data of the ground level cannot be used in this tall building, especially super tall. So in this paper, I used the weather data measured from the radius on the. And the air movement, usually normal buildings, the inside of the building's vertical air is not very big. But in high-rise building, the stack effects affects a lot, and this also has a very big impact on energy consumption as well. So this is a way of how I want to talk about this paper. And the chapter 2 is radio zonde, which is the measuring tool, the weather measuring device that observes weather data in upper level. It looks like a balloon here, and it goes going up and transmits data to the ground level. In the site of University of Wyoming, Department of Atmospheric Science, we can see the data from this data collected from the radio zonde worldwide. And in this paper, the weather data has been weather data has been observed from radio zone in Osan, where is the nearest place from Seoul, metropolitan city, has been used as reference data. And in picture here is weather data temperature and wind speed from data is observed between the ground level and 200 level. And this is the data from 800 and to 1,000 meter level. It shows very obvious difference in temperature and wind speed as well. And this is a arrangement of table for annual, and you can see it's a very obvious difference here. But although the number seems like very obvious, that the point of this table is it is the factor that we have to be that has to be considered, not to ignored or just simplified. And to conduct a simulation in this paper, I used a hypothetical building that is 1,000 meter high and 200 stories. And because this is a paper about effects from that is being affected from the outside, so from the outside to inside, the 6 meters up zone is considered a perimeter zone, which is quite affected a lot from outside. And it's vertically zoned to every 200 meters, that is 40 floors. And so it has whole building has 5 zones here. And these are the information data that has been used in simulation. In normal simulation, the infiltration level is normally fixed, but in this simulation, to find out the effect from the wind speed, the infiltration the value is set to be different according to the wind speed level. And here are the simulation cases. I conduct 2 simulations. One is effect from weather, and the second one is effect from the stag effect. And according to each zones, the different weather data has been used, and this value is set to when the outside wind speed is 3 meters per second, then this infiltration value has been used. And in stag effect, I compared those 3 different height of the buildings. From the result of the first simulation, it shows a lot of difference between when we use single weather data and vertical different weather data. It shows a lot of difference. This is annual sum up building load, heating and cooling load. The cooling load decreased about 27%, and heating load increased about 3 times higher. So if buildings envelope or HVAC systems are designed only based on the single weather data that is measured near the ground level, it can be result inappropriate. And the second one is the graph that shows the difference between all the levels, how the heating load and cooling load per square meter, kilowatts per square meter year is being shown. And this reference level means how is air tightened. This number means it's more air tightened building, and this is less air tightened building. And it shows differences between not only for the ground from the zone that is very near to the ground level to the higher level, but also the infiltration is quite important in high-rise building. It's more important when it gets higher. And this is a monthly building load. You can see the bigger difference, especially in the winter season, because it's getting colder outside and the wind speed grows. And although it seems there's no many difference in cooling load, but in annual sum it is quite a big value. And this is a load breakdown from the zone A and zone E, which is the lowest and highest level. And you can see there's no big difference in solar level, because all things are not considered from the effect from the other buildings. The simulation is just assumed there's no building near there. So infiltration and ventilation gain and the conduction from the building envelope, it shows big differences. And let's move on to simulation 2, which is knowing how the sag effect affects to the building cooling and heating load. This one is not considering the sag effect, just like a normal simulation. And this one is considering the sag effect. And it also shows a big difference. And according to the height, this one is a 40 stories building, and this one is 120 stories, and this one is 200 stories buildings. And it shows very big differences according to the stag effect. In stag effect, usually the wind comes on the underside of the building, and it goes out from the upper side of the building. So it shows a lot of differences. This is the monthly data, and this is airflow rate of each year, which is winter and summer. And you can see this affects a lot to the building load. So let me reach the conclusion. The first conclusion is the simulation method should reflect, especially in tall buildings, we have to consider the wind speed and temperature changes between the ground level and the higher level, because they are dominant effects to the heating and cooling load. In this study, the vertical climate change were considered using the radios and the data. And the last thing about the calculation is the weather measurement about the vertical differences and air movement from the stack effect. Those both things are very important. So when simulating the building, these things have to be considered. Thank you for listening. This is the end of my presentation.
Well, any questions from audiences? Well, let me ask one question. When you calculate the cooling and heating load, you use the air change method for calculation of the heating and cooling load. So I just ask, you measure the wind velocity of each level from of the height. So why didn't you use your wind velocity data for calculation of the infiltration load? Because if you have a wind velocity, you can use your wind pressure coefficient, and then you can use a leakage area method for infiltration load for heating and cooling.
Can you summarize the question? Can you summarize the question?
So I just ask, why didn't you use your wind velocity data to calculate the infiltration load? You just fixed the 0.5 ACH for calculation of the infiltration load. So you can use your wind velocity data and wind pressure coefficient to calculate the infiltration load.
That is that ACH, the value means the air tightness of the building. That is the representation of the air tightness. And
yes, but the air tightness, building has its characteristic air tightness, but the total air exchange rate will be changed by the wind pressure, external wind pressure. So you didn't use that data, I think. I understand. Okay, let's talk about later. Okay. Any other questions? Okay. You can use your microphone.
I'm a structural engineer, so I don't understand this real well, but your graphs seem to show that the stack effect increases the cooling load and decreases the heating load. Was that correct?
Yes.
How does that work? Can you explain that to a structural engineer?
You mean the load being different from the height, according to the height?
How the stack effect
Ah.
increases cooling load.
Well, it actually increases the heating load of the building because pardon? Okay.
Okay, for further discussion, please use the intermission after the session, please. Okay, any other questions? Okay, thank you for the presentation.
Thank you.